Hey everyone, we've been talking about graphing linear inequalities, and I want to just go over a few more things with you guys that you seem to be missing, and hope to clear up some confusion. So with graphing linear inequalities, it's a lot like graphing a line, except we shade, and we determine whether our line should be dotted or solid, and we talk about the constraints a little more. What's included, what's not included, what things work and what don't. So looking at this first graph, it says graph all of the solutions of the following inequality. Y is greater than or equal to 2/3 x minus 3. Well, just like the other equations that we've been working with, we still have a slope and a y-intercept. So go ahead and identify those now. You should have said that your slope was 2/3 and your y-intercept is -3. I'm going to go to my graph and I'm going to go over to, and I'm going to begin with -3, my y-intercept. So go to 0, -3, and I plot my point. Then my slope tells me that I need to rise 2 and run right 3. And I can continue to rise 2 and run to the right 3. And I encourage you to do that because when you shade and you're finding your solutions, it will make a lot more sense if it's all the way across the graph. So then I'm going to go back to my y-intercept and I'm going to do the same thing. I'm just going to do the left side. So I'm going to go down 2 and to the left 3, down 2 and to the left 3, down 2 and to the left 3. Once I have that, I'm going to graph my line. Now, why did I use a solid line here? It's a great question that I hope you can answer. This sign right here, the greater than or equal to sign, tells me that not only will my solutions be greater than 2/3 x minus 3, they can also be equal to 2/3 x minus 3. So that means all of these solutions, these points that are on this line, will satisfy this inequality. But now I've got to determine if the points above the line or the points below the line will satisfy this inequality. Now you can pick a test point, all right? So this says that y is greater than or equal to 2/3 x minus 3. That means automatically we need to think, okay, so this can be greater than -3. The solutions can. So I'm gonna pick an easy one. Greater than -3, 0, 0, in terms of greater than or equal to. If I'm looking at my y value of -3, and the point 0, 0 is definitely greater than -3. So I'm going to try that out in my inequality. So my inequality was y is greater than or equal to 2/3 x minus 3. And I'm going to substitute in the point 0, 0 that I've picked as my tester point. So y is 0, greater than or equal to 2/3, and my x value is 0 minus 3. Now I do a little bit of math. And I come up with 0 is greater than or equal to, well, 2/3 times 0 is 0 minus 3. And if I subtract 3 from 0, I should come up with 0 is greater than or equal to -3. Now, is that a true statement? Yes, 0 is definitely greater than or equal to -3. It actually qualifies in the greater than category. So when I shade, because 0, 0 qualified as a point, that satisfied my inequality, when I shade, I'm going to shade all of this above the line because all of these points above or on the line satisfy the inequality. Alright, so we're graphing a line. We determine if it's a dotted line or a solid line. Solid lines are greater than or equal to or less than or equal to. Dotted lines would be greater than or less than, one of those two. So that equal to sign makes my line solid. Alright, there's no equal to sign, it's going to be dotted. So check this next one out. You want to graph all of the solutions of the following inequality. Y is less than -1/4 x plus 9. Okay, you guys do that on your own right now. I'm going to do it. We'll check and see if our answers match. Okay, you check your answer with mine. I got that 9 is my y-intercept. My slope was -1/4. That means I needed to rise 1 and run 4. Now, the negative tells me my slope is going in a downward direction, so my line should be headed downhill if I look left or right. Then I picked a tester point. I picked 0, 2. You could have picked 2, 4. You could have picked 6, 6. It doesn't matter what you pick. I picked a point below the line. If you had picked a point above the line, you would have known that that does not satisfy the inequality. Because when I work this out, 0, 2, it's below the line down here. And my inequality symbol said y is less than. So it's going to be less than 9. That's what it's telling me. So I checked it. 2 is definitely less than 9. So if 2 is less than 9, all of these points below the line will satisfy the inequality. Now, key here, if you put a solid line, you are incorrect because this is a dotted line. It is less than. There's no equal to symbol, so you have to only include the points below the line. The points on the line are not included. All right? So, keeping all of that in mind, check out this context problem. All right? You're at this greenhouse in early spring, and there are many plants to repot. The plants have to be watered after they're repotted. If it takes Ben 5 minutes to repot and 2 minutes to water each plant, and he has at most 2 hours before the greenhouse opens, what inequality represents the time Ben has to repot and water the plants before the greenhouse opens? What is the graph of the solutions? So first, we've got to write an inequality. Then we've got to graph it. Notice those two statements. It says, what inequality represents his situation? And then, what is the graph of the solutions? So, when we do this, we need to go ahead and we need to make sure we write this incorrectly, correctly. So when we look at this, it's going to take him 5 minutes to repot and 2 minutes to water each plant. And he has at most 2 hours to do this. So we don't know how many plants he has, but we do know what 2 actions he needs to do. So we've got to determine who's X and who's Y. I would say X is repot, and Y is water. Now, could you swap these? Most certainly. It's all up to you. So then, if this is the situation I have going on, I'm going to say that it's going to take him 5x, because that's his repot, plus 2y, that's his watering, and he has at most 2 hours. So he has 2 hours to do this. So he can't go over 2 hours, but he can be equal to 2 hours, but no more. All right? Now, here's the problem. This is in 5 minutes and 2 minutes, but this right here is hours. So this goes back to our unit conversion piece. We have to convert this 2 into hours. So we have to convert this 2 from hours into minutes. So how many minutes are in 2 hours? If you said the answer is 120, then you are correct. So really, we've got 120 minutes to do this. Now, I don't know about you, but I don't like to graph things in standard form. So let's swap this inequality around to be in slope-intercept form. So do that right now. See what you get. All right. When I converted this into slope-intercept form, I got that y is less than or equal to negative 5/2 x plus 60. So we've got a slope. We've got a y-intercept. All right. But how are we going to number this graph? What would make sense? He's going to have up to, technically, 120 minutes to do this. So if I draw my t-table, x and y, I know that if I don't repot any, I can water how many? 60. But if I repot 1, what happens then? Alright, to check out my inequality now, I did my t-table and I figured out that if I repot one plant, then I can water 57 and a half others. Okay? But if I plant 2 plants, repot them, I can water 55 other plants. So I looked and said, ooh, well, when it's even numbers, it seems to be nice, round, pretty numbers that aren't decimals. So I tried 4, and I plugged in 4 for x, and I found out that, hey, I can water 50 plants if I only repot 4. So then I wanted to know, okay, well, where will this stop? So I wanted to know if I watered no plants, 0 plants, how many plants I could repot. And so when I worked that problem out backwards, I found out that x equals 24. So that means I can repot 24 plants if I don't water any. So if this is the case, I can graph this inequality. And what I did to determine what I needed my x values and my y values to be is I looked at this t-table and I noticed that, well, 57.5, that's not going to be very fun to graph. But 0 and 60, that's pretty easy. 2 and 55, 4, 50, those are easy numbers to graph. So what I did is my x values, which represent the number of plants I can repot, those are represented by, I was counted by 2's. So this is my repot down here. And then my water, the number of plants I can water, that's going to be over here on the y-axis. So if you will, go ahead and graph that inequality. And remember, does it get a solid line or a dotted line? Determine that and determine where you're going to shade. I'm going to go ahead and do that and we'll talk about it. Okay, so here's what I got. I got that we can water at most 60, but then repot none. Or we can repot at most 24 and water 0. But then I know that I can't do any more than 60 or any more than 24. So if you look, it says in my equation I have y is less than or equal to negative 5/2 x plus 60. So that means y has to be less than 60 over here. So if it's going to be less than 60, it made sense for me to shade all of this down here because all of these points would satisfy my inequality. And you could have picked a test point in order to determine that. Now, I didn't put arrows on either end of my graph. Why? Why did I not put arrows? I didn't put arrows because y can only be less than or equal to 60, and x can only be less than or equal to 24. It can't be any more than that. So I'm limited. I can only go up to 24 and I can only go up to 60. I can't go any further. So that means the arrows are not there. My problem has constraints, all right? There are limits to what I can do. So look at this problem about Toya. I want you guys to work it out on your own. I'll show you the answer at the end, all right? So see what you can do with this. All right, so here's what we found out. I found out that x plus y would give you less than 3. It says she has less than 3 hours to spend on her workout. So she doesn't have 3 hours. She has less than that. So what that means is that she should definitely have a dotted line since there's no equal to. She has less than 3 hours. I originally wrote my equation in standard form. It would have been x, which represented biking, and then y, which represented her time running, had to be less than 3. But graphing that is not very fun, so I moved my equation around and solved it so that it would be in slope-intercept form. So my inequality now is y is less than negative x plus 3. That made my y-intercept, it made it 3, and it made my slope negative 1. So y-intercept, here's 3, slope is negative 1. And then I went down here and I did my t-table just because that helps me number my graph. And I realized that I don't need very large numbers here. So I was able to spread out my x values and spread out my y values here. So once I'd spread them out, I started graphing my points. And I started at 3, And we're going down 1 and over 1 each time. So I started at 3, and I went down 1 over 1, and then down 1 over 1, and down 1 over 1. Now remember, my line was dotted because it wasn't equal to. And then I knew that I couldn't have more time. So shading up here, it doesn't make a whole lot of sense because she's only got 3 hours. So it has to be in between 3 here and 3 here, because she can either bike for 3 hours or she can run for 3 hours, but she's got less than that amount of time, so she can't do it for any more than 3 hours. So that meant I needed to shade below the line, and my equation tells me that because 3, it's going to be, y has to be less than 3, so that means I need to shade towards the bottom. Okay, I hope this helps. I hope it's cleared up some of your misconceptions, and I hope you start doing much better on this than you have been.